Welcome back to Nature of Code in Rust and GGEZ. Today we're going on to exercise 1.8. Try implementing the above example. So that's the example we just did, where we have the ball accelerating towards the mouse. With sort of like, they talk about how we could have a variable acceleration depending upon how far away the object is, so the ball to the mouse. So basically, try implementing the above example with a variable magnitude of acceleration, stronger when it is either closer or farther away. Let's go ahead and do this. So I've got the exact same example that we had for last time, which was example 1.10. We have a ball that's just constantly traveling towards the mouse. It's I think it's accelerating at a rate of 0.5 per frame. So we want to make a change to this. Well, so one thing I was thinking of is I actually in my mover want to update, the update, and to not do a lot of this stuff anymore. I want my update to just be focused on updating velocity, velocity with the acceleration, limiting the velocity, and then moving the location. So because of that, we're not going to need this context here anymore. Instead, what I'm going to do is I'm going to come down here and create another function. So pub function, I can't use move because move is a reserved keyword in Rust. So we'll just call, maybe we can call it like walk itself. We are going to need the context here, and we're not going to need to return anything. So for right now, the basics are we need to do the exact same thing. We need the location of the mouse. So we need mouse equals, let's get the mouse location, pass it in the context. Then we're going to get the direction. So it's our mouse minus the self dot, sorry, not direction, location. Our locations, that gives us a direction from the mouse to the location. Okay, then I want to do the same normalization. So direction dot normalize. However, now I want to scale this up by some amount. So if we come up to our mover class, we have this scale here, and this should be fine. I should be able to use this scale to determine how to make it move faster or slower depending upon the distance from it is. Well, if I want to do that before I normalize, I actually need to have the distance. So let's get that. Distance equals the direction. We use the magnitude. That needs to be an equal sign to get this distance. I can scale that immediately too. So I can just multiply it by self.scale. Then I want to, I want to now scale our direction based upon this new distance. We can actually make this a scaled distance. So we'll do a direction multiply scalar with the scaled distance. And then once we have that, we can just assign direction to acceleration. So self.acceleration equals direction. Then when update comes around, it will go ahead and update the velocity with the acceleration and then the location with the velocity. All right, so far so good. We're gonna need to remove context from this and self.mover.walk. So if we run this, it's actually we can tell that something is different. The ball hovers right next to the mouse. It does fly, fairly normally looking, but doesn't really pass the mouse very well. So the easiest way for me to sort of show the big difference between the first version, the version of example 1.10, is to, in our mover, update our scale. So instead of 0.5, let's make this really, 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 really small. So like maybe 0.01. This is going to multiply 0.01 with the distance, and that's going to become a much smaller number. So the farther away that we are, the bigger a force we're going to give to this acceleration. Let's go ahead and try this now. So we sort of move here. It looks very similar, but if we go past it, it can't turn around. I mean, it can, but it's a lot harder. But the closer I am to the ball, the faster it can stop. And notice it's barely moving here, but it gets really fast the farther away we are. And so that's basically our acceleration being dynamic. The farther away it is, the more acceleration that it's getting. We can do the opposite if we wanted to play around with that scale too. Maybe make it a larger number. That might be a little bit too much for us, so we'd have to play around with it to get the exact result that we want to get. However, that is exercise 1.8. We've implemented variable magnitude of acceleration. I'll see you in the next example, which will be 1.11. Hope that you have a great day. Happy coding, and see you then. Bye.